All right, let's take a look at dividing polynomials. We have two main ways that we use to divide polynomials. And actually this first one, long division, this works always. So to me, this is the best one. It works all the time. We do have another kind called synthetic division. This technique only works when you're dividing by a binomial in this particular form, x minus k. And so we're going to talk about both of those techniques. Let's start with long division first. You may recall from previous math classes, dividing, learning how to divide. And so what I'm going to do is I'm going to do a regular division problem right here on the side, kind of right along with the dividing polynomials, because the procedure is the same. I know it looks quite different, but the procedure is exactly the same. So what do we do when we're dividing just regular numbers? So we take this 2, we decide how many times it will go into this first number. So 1, so then I multiply back out 1 times 2 is 2, and then I subtract, bring the next number down. All right, so let's hold on to that thought. So now let's look at dividing polynomials. The first thing that I would like for you to notice is that the dividend, so this thing under here, if you recall, that's the dividend. The dividend needs to be in descending order. So my exponent is a 4 and a 3. Ooh, I'm missing a 2. Okay, I'm not allowed to miss anything, so I'm going to have to insert a 0x squared there. And then I have 1, and then I have a constant. Notice how they inserted 0x squared. You can't miss 1, one of the variables. You've got to insert 0 in front of it. It's kind of just like a holding place. 0 times x squared is just 0, so you're really just putting in like a holding spot for that. All right, so we've got that set up. We're dividing by this polynomial, x squared plus 3x plus 2. So what do? Well, just like up here, we take the first number, the 2, put it into the 2. So we just take this first term, x squared. X squared goes into 2x to the 4th how many times? In other words, if you multiply blank times x squared, you would need to get 2x to the 4th. Okay, so we see that 2x squared would be what would be divided. So again, if that doesn't make sense, let's just put this out. We're dividing, right? We're dividing 2x to the 4th by x squared. We can see that this would yield 2x squared. And that's what we have right here. All right, so then what we do, a little bit different than this technique. So we said 2 goes into 2 one time, 1 times 2 is 2. All right, here we go. 2x squared times x squared is 2x to the 4th. 2x squared times 3x is 6x cubed. 2x squared times 2 is 4x squared. Then what we want to do, now here's what I always do. I always put parentheses and then a subtraction, because I am just so afraid that I'm going to forget and I'm going to, make a sign error. That's a common error for all of us, right? I'm sure everybody has made a sign error. So I want to make sure, bring it to my attention that I'm actually subtracting. So I subtract those terms. Of course, that's 0. 3x cubed minus 6x cubed is negative 3x cubed, and so forth. And then I bring down my next number. Just like I did over here, I brought down the 3. Same procedure. Now we go again. So 2 goes into 3 one times, and then I multiply out 1 times 2 is 2. I subtract and bring down the next number. Same procedure here. So we've got, again, now we're just using this first term to divide. So we brought down this 5x. So now we go again. So x squared goes into negative 3x cubed, negative 3x times. So we again multiply back out each of those terms and get this sequence. Again, subtracting, and then we move on. So we just keep going on that procedure until we get to a remainder, until x squared, which is our first term, won't go into negative 4x. It just won't, right? So that means that this part right here is the remainder. Okay, so how do we write this? So we write down, this is called the quotient. We write the quotient down and then plus the remainder over the divisor. Okay, so the remainder over the divisor. And this is how the answer is written. Okay, that's just an example that, and we're going to do some, ourselves, but that's just an example that you have if you want to investigate each of the parts. It's already written down there for you. So that's long division. So let's look at synthetic division. And so synthetic division is a more simple kind of structure. And so some students really kind of like it, but I will just kind of warn you that it only works sometimes, not all the time. So how do we do this? How do we do this procedure? Well, same scenario in that we need to be sure that all of the variables have descending exponents. Again, right now, crazily enough, we're missing an x. I'm missing a 0x. I'm missing an x, so I have to insert a 0x. And you can see that's what they did right here. This first line of numbers is the coefficient of each of the terms. Okay, and the 0. So we write down the coefficients of the terms. We are dividing by x minus 3. So what number do we put here? Well, the number that we put here would be the 0 of this. We would call this a factor, right? So if you recall, if this is a factor, the solution, or 0, would be 3. And so that's why this is a 3. So we're dividing the 3 in there. Okay, so that's our setup. We have the coefficients lined out. We've got that number that we're dividing by. Then we bring down the first number, -1. And then this is a procedure of multiplying and adding. That's what we do. We multiply. I'm going to take my 3. I'm going to multiply it by the -1. And that gives me a -3. Okay. Then I add down. So I am adding here. I add down and I get a 1. Then I take the 3 and I multiply the 3 times the 1. Put it here. Then I add down and get a 3. And I keep going on that procedure till I get to the end. This last number is the remainder. And so what we have to do when we're done, and we need to translate this back to what would the answer have been if we were doing it, long division. So let's see. So if this is the remainder, we see it right here, the remainder over the divisor. Then the number in front of it was the constant. And then the number in front of that was that, to x to the first power. And the number in front of that was x squared. And so that gives us our final answer. Okay, and so that's an overview of those two techniques. All right, so let's move on to some examples and let's practice that. So the very first example, actually, I know you're like, oh my gosh, that looks crazy. Well, I'm actually going to do the first example a little bit differently. I'm not going to use long division and I'm not going to use synthetic division. I'm going to do something that only works when I'm dividing by a monomial. Okay, this technique only works when dividing by a monomial. Let's remind ourselves of that vocabulary word, monomial. Monomial is one term, right? It's a one-term polynomial, monomial. All right, so how does this technique work that we can use? It's actually a more simple technique, which is why I'm going to show it to you. But again, it's very, I can only use it when I'm dividing by a monomial. Basically, what I'm going to do is I'm going to split this big gigantic fraction into 3 little fractions and then simplify each fraction. So I've got 6x to the 4th y cubed over 3xy plus 12x cubed y squared over 3xy minus 18x squared y over 3xy. I think you can see all I have done is I have simply I rewrote it. I rewrote that one big fraction into 3 little ones. because I have a monomial, it's very easy to do. And then I simplify each of those fractions separately. So 6 divided by 3 is 2. X to the fourth divided by x would leave me x cubed. Y cubed divided by y is y squared. Okay, that was nice. We took care of that. Let's look at the second fraction. 12 divided by 3 is 4. X cubed divided by x squared. And then that leaves me y squared over y is y. Okay, very nice. Minus 18 divided by 3 is 6. X squared divided by x is x. And the y divided by y is 1. So that leaves me with this answer. Now, it's really kind of nice that all the fractions went away. That isn't always going to be the case, but it was for us here. And so that's just a different way to divide polynomials. And again, I just want to highlight, this only works when you are dividing by a monomial. Otherwise, you're going to have to use one of the other two techniques. Okay, here we go. Let's start on this one. Since I'm dividing by 2x plus 1, that's not in the form, this one above. For synthetic, we need it to be x minus k. It's not in that form, and besides, I'll just be honest, I like long division better. It's so much more fun. So we're going to do long division here. So my divisor is 2x plus 1. I'm going to put the dividend in here. So I've got to the fourth, cubed, squared, to the first. Oh wow, we have everything we need. 4, 3, 2, 1, constant. Oh, we don't have to insert any zeros. That's nice. So let's just write this onto here. 2x to the fourth plus x cubed minus 2x squared plus 9x plus 5. Okay, here we go. Our first one. All right, 2x goes into 2x to the fourth. Let's see. In other words, what would I multiply 2x by to get 2x to the fourth? X cubed, right? I would just multiply by x cubed. So x cubed times 2x is 2x to the fourth. X cubed times 1 is x cubed. I don't have anything else to multiply by, so we stop. I'm going to do my, parentheses thing again because I don't want to make an error on a sign error. That would just be terrible. All right, so then actually I have nothing left over, so we bring this down, minus 2x squared. We should probably go ahead and bring another term down because I have 2 here. So let's bring down a 9x. All right, here we go again. So 2x goes into negative 2x squared. Let's see, and negative x times 2x is negative 2x squared. Negative x times 1 is negative x. Here we go, we're subtracting. That goes to 0. Negative 2x squared minus a negative 2x squared is 0. So 9x minus a minus x. 9x minus a minus means plus, so 9x plus x is 10x. Now we bring the other number down. Okay, great, we're doing good. Let's keep going. So 2x goes into 10x. Let's see, 5 times. So 5 times 2x is 10x. 5 times 1 is 5. Oh, look at there. We don't have a remainder. Okay, that's kind of nice. We don't have a remainder at all. So we write down our answer is going to be x cubed minus x plus 5 with no remainder. So since the remainder is 0, I don't have to put, plus 0 over 2x plus 1. That's all I need to do. Yay! All right, let's try another one. Okay, let's try this one. So I'm going to divide by x squared minus 2, so I'm going to have to use long division. Let's see, I have x cubed, x squared, x to the first, 7. Okay, I don't have to put in any zeros. That's nice. Here we go. X squared minus 2 is our divisor. Our dividend is 2x cubed plus 3x squared minus 4x minus 7. Okay, all right, so here we go. X squared goes into 2x cubed. In other words, what would I multiply x squared by to get a 2x cubed? Well, I would multiply by a 2x. 2x times x squared is 2x cubed. 2x times negative 2 would be negative 4x. Ooh, so those don't line up. If you kind of look here, those don't line up. Okay, so I've got a squared and a first. All right, well let's just move this down so that I can combine like terms. All right, so this would be minus 4x. Okay, so let's double check to make sure we got it right. 2x times x squared is 2x cubed. 2x times a negative 2 is a negative 4x. All right, so 2x cubed minus 2x cubed, well that's nothing. 3x squared minus 0 is 3x squared. Negative 4x minus a negative 4x is 0. And then I bring down my last term, which is a minus 7. Okay, here we go. So x squared goes into 3x squared. Let's see, 3 times. So 3 times x squared is 3x squared. 3 times negative 2 is negative 6. Okay, so we're subtracting 3x squared minus 3x squared. Well, that's nothing. Negative 7 minus a minus 6 would be negative 7 plus 6 would be a negative 1. Okay, well, I do have a remainder this time. So let's write down our answer. So our answer would be 2x plus 3. And then I always put plus, and then just whatever the remainder is, I just stick it on top of the divisor. I'm not going to be fancy and try to put a subtraction sign because that can lead us into some trouble. So let's just always add the remainder, whatever it is. So I add the remainder, which is negative 1 over x squared minus 2. Yay, there's our next one. Okay, so last one, let's work. So this is in the proper form, x minus k. So let's do synthetic division here. So we're going to do synthetic division. Just practice that little technique. Okay, so I have to have my exponents in descending order. 3, ooh, I don't have a 2, so I'm going to have to insert a 0x squared. So 3, 2, 1, constant. All right, so here we go. How does this work? Well, I'm going to write out the coefficients. So I've got a 1, I've got a 0, I've got a negative 7, and I have a 6. And the divisor is basically what, so we have to say, what is k equal? You know, our form, it has to be in the form of x minus k. So we can see that in this particular case, k is 2. Okay, so I'm going to divide by 2. I put that in the box. Then I draw a line down here, and we bring down the first number. Okay, here we go. It's a series of multiply, add, multiply, add. So 2 times 1 is 2. Add down, I get 2. 2 times 2 is 4. Add down, I get negative 3. 2 times negative 3 is negative 6. I add down, I get 0. So my remainder is 0. I don't have a remainder. Okay, that's nice. So that means that this number is the constant. This number is x to the first, and this number is x squared. We just can fill it out backwards. There are other ways to do it, but I'm just kind of getting us in a pattern. So we're just going to fill this out backwards. So I would have 1x squared plus 2x minus 3, and then, you know, there's no remainder. So that would be my final answer. And there is our lesson on dividing polynomials.